Hello, I'm Brad Brim of Cadence Design Systems. Welcome to Sigrity Tech Tips. Today we bring you another installment of how to sign off your IC design package. Our video today will show you how to efficiently extract electrical models for low-cost IC packages made of lead frames. Many high-performance, high-cost IC packages utilize a multi-layer build-up structure. However, when IC designs are suitable, semiconductor companies prefer to utilize a low-cost, single-layer chip carrier known as a lead frame package. Because lead frame packages are physically much different than multi-layer packages, different analysis engines are required to model each type of package. This means IC package characterization engineers must run different tools for different types of packages. Switching back and forth between tools causes confusion, bad models, and possibly loss of business when customers receive models they cannot use. With Sigrity, modeling of IC packages remains consistent because characterization engineers remain in the same EDA tool regardless of package type. Our single environment provides access to all of the required analysis engines for any IC package, from a simple 20-pin lead frame to a complex 10,000-pin ball grid array. This enables getting high-quality models into the hands of your customers faster, which in turn leads to earlier sales and quicker profits. In this video, we will utilize Allegro Sigrity SI Base and the Package Assessment and Extraction option. To learn more about these products, visit us at www.cadence.com. Now, I will turn it over to my colleague, Charlie Shi.
Thanks, Brad. This is Charlie Shi. I'm pleased to introduce Sigrity Xtract M Quasi-static solver for Leadframe package modeling in this demo movie. With the new quasi-static solver option in Xtract M, now you can access 4 solvers options in the same environment for different package structure. The workflow in Xtract M remains the same for different solver options. The quasi-static resistant inductance and static capacitance can be selected separately altogether. The simulation results can be reused to generate the SPICE model. In Xtract M, there is a specific workflow for leadframe package modeling. It supports the DXF to SPD file synthesis. The components and the netlist information can be automatically created for the leadframe packaging. It also supports out-lead profile setting to build up a complete 3D leadframe structure. Once the leadframe structure is built, the extraction step is the same as the other package types. In Xtract M quasi-static resistance inductance solver option for leadframe packaging, there are 2 RL results tables. One is for full RL metric for the selected nest. The other is a self-RL table. Those RL metric can be reduced by assigning some nest as floating, lump, or reference. Different reduced metric results can be displayed together to find out the optimized design. Similarly, in static capacitance iteration, there are 2 capacitance results. One is for full capacitance metric for the selected nest. The other is a self-capacitance table. Those capacitance metric can also be reduced by assigning some nest as a floating, lump, or reference. Different reduced matrix results can also be displayed together to do what-if analysis. When selecting both quasi-static resistant inductance and static capacitance solver option together, it provides more comprehensive reports. In addition, with the full RLC metric and self-RLC table, it also provides RLCK-based SPICE model and IBIS model for time domain transition analysis. In this demo, I'm going to introduce leadframe package synthesis flow in Xtract M, set up out-lead profile to complete the 3D structure for iteration, and introduce quasi-static RLC iteration. Now we are in Xtract M environment. In the workflow, we are going to import the DXF file for the leadframe package. Cadence speed editor will be automatically opened up to handle the DXF to SPD synthesis. In this step, we are going to map the DXF layers to SPD layers, including inner lead, die, pad, and bonding wires. In this step, we set up the inner lead thickness, and here we select the inner lead object to be translated. Now the metal object selection is completed. The tool automatically creates terminal to connect to the outer lead. On the four corners, we delete the undesired terminals. Now the synthesis is completed. Bonding wire and the inner lead layer is created. Now we are going to send back the SPD file to the Xtract IM. This is the bonding wire, and here is the inner lead. Net name is also created. Next, we are going to set up the package. This is a wirebond Leadframe with outer lead package. We set up the die and outer lead components. In the layer stack up, we are going to add a layer for outer lead and adjust thickness for die thickness, molding compound thickness. In the lead, here is to set up the outer lead profile. We adjust the outer lead thickness. Here is to set up the bonding wire diameter to a realistic value. Now the 3D structure is completed. You can check it in the 3D viewer. Save the package setup to a workspace file. Now we can select the critical net to extract the RLC by quasi-static solver. We select Add Net for this demo. We treat the middle die pedal as a folding net. Click the field solver. By default, it is hybrid solver. We select the quasi-static RL iteration. First study. Now the simulation is started. You can check the performance checker to monitor the memory consumption and the convergence situation. Now the simulation is completed. You can see the resistance and the inductance plus. You can also see the RL metric and self-resistance inductance. You can select some nets to set as the reference reduce the matrix, and you can compare the original matrix and the reduced matrix. Now we are going to extract the capacitance by static capacitance solver. The package setup is the same as the previous run. Similarly, you can check the convergence situation during the simulation. Now the simulation is completed. It provides the capacitance plus and also the capacitance matrix self-capacitance. Again, you can select some nets as a reference, ground reference, to reduce the matrix. And you can compare the reduced and the original capacitance matrix. Finally, we are going to use the existing result from previous simulation to generate the RC spice model. The simulation is completed immediately. So now you can check the spice model, including T-type, Pi-type, IBIS model, and RC table. Thanks for watching this video.
Thank you for watching another edition of Sigrity Tech Tips. For information on products used in today's video, click on the links below or contact your local Cadence sales representative or Cadence channel partner.